On number 9, I want to look at my trig ratio, square root of 3 over 2. Square root of 3 should be a huge hint. That's my 30, 60, 90 triangle. Because I know in my 30, 60, 90 triangle, it goes 1, 2, square root of 3. And notice I only have 30s and 60s on here. So when I look at the sine of 30, the sine of 30 is 1 over 2. It's not the sine of 30 then, is it? Because the sine of 30 would be 1 over 2. That doesn't help me out. Cosine of 30, adjacent, square root of 3 over 2. So we know the cosine of 30 is the same as the sine of 60. Now, and then I don't use tangent, because tangent of 30, I'd be 1 over the square root of 3, and I got the square root of 2 in there. Question number 10. I want to solve the triangle. I don't care how you solve it. I want you to round the angle measures to the nearest degree, whole number, and the side lengths to the nearest tenth. Let's start with the side length. I can use Pythagorean theorem to find the sides, because that's probably the easiest way to do this. 8.3 squared equals 7.2 squared plus, we'll say, BC squared. So if we take 8.3 and we square it, and we subtract 7.2, and we square that, and then we take the square root of that answer, BC, sorry about that, the calculator isn't working, BC is 4.1. I don't want 4, I don't want 4.13, I want 4.1 for BC. Now, to solve for either angle A or angle B, I like to do things in alphabetical order. Let's use angle A. Let's use the sides I know, because I know this is 7.2 and 8.3, so I'm going to use cosine of angle A. So the cosine of angle A is 7.2 over 8.3. So to find the measure of angle A, we take the inverse cosine of that. So inverse cosine of 7.2 divided by 8.3, and we get 30 degrees, rounded to the nearest whole number. The measure of angle B then, because there's 180 degrees in a triangle, or because in a right triangle, my acute angles are complementary, the measure of angle B is 60 degrees, and that's where you get that for an answer.